Hello everybody. I'm going to explain the volume of cross-sectional solids as it applies to basic integral calculus. If you plan to take calculus, whether through the AP course, in college, or at another program, you will definitely come across this concept more than once. This is how I understood it, and I hope you found it interesting too. Imagine that you are asked to find the volume of a solid. Its space is the area between two curves, and its cross-sections are two-dimensional shapes perpendicular to the x-axis. Now, why should we use an integral to evaluate the problem? Specifically, why would we put the function for the area of cross-sections in the integrand to find the amount of space inside the solid? Well, the way I saw it was in 3D printing. A 3D printer uses a process similar to integration. It imagines an object as thousands of extremely thin slices, only around 0.2 millimeters thick. The printer can add layer upon layer of material horizontally to create a shape with very precise definition and volume. In terms of calculus, we think of each cross-section as an infinitely thin layer of a solid. Adding an infinite amount of these layers until we complete the solid gives us an approximation of its volume, almost infinitely perfect. The integral does exactly this. It adds up all the cross-sections of this object, and an infinite sum of infinitely small widths helps us transition from 2 dimensions to 3.